And I now recognize myself for 5 minutes of questions. This is definitely an intimidating topic. Thank you for your testimony. Now, Dr. Kurose, conversations around STEM education are often closely tied to demand for certain jobs. And without knowing the exact workforce needs surrounding quantum just yet, how do we prepare for such a workforce, and how can young people be directed, if they're interested in this, what should they be doing now?
Thank you very much for the question, and it's really a great one. And maybe let me highlight education and educational opportunities at different levels. And I'll start with at the graduate level, because I mentioned that in my testimony. Remember that the generation of researchers who are going to push us forward in QIS, they're in labs now, and they're graduate students, and they're postdocs working in those labs now. Those researchers will then be taking their education out and spreading it and using it in industry, for example. At the undergraduate level, we're seeing courses now in quantum. We're seeing seminar courses there. So I think at the undergraduate level, we're beginning to see the educational opportunities appear at the undergraduate level. When we think about the workforce more broadly, I think we really need to think about the STEM pipeline and address issues in K through 12. I would say there areas in particular, the notion of computational thinking, some of the activities that the National Science Foundation and other agencies have taken in terms of computer science for all and computer science principles, a rigorous access to a rigorous and engaging computer science education at the high school level will really help prepare the students in middle schools and in high schools for engaging in computer science and in STEM more broadly, I think, at the college level. Maybe one other area that I might like to highlight is that when you look at the people that you've invited here to testify, that you'll see you have engineers, you have computer scientists, you have physicists, and it's really going to take participation from across all of the STEM disciplines to make QIS really happen. And so it's important broadly across STEM that we train the next generation of researchers. Yes, my area is computer science, so I think it's incredibly important, but this is an area that all of STEM, engineering, mathematics, physical sciences, chemistry, computer science, are going to have to be involved.
Okay, and then how would a national quantum initiative meet the challenge to attract and retain U.S. talent in this field, given the significant challenges for that? I guess for all of you. Any of you who'd like to answer on that?
So should Congress and the executive branch decide to have a quantum initiative in this area, we'd be happy to work with you to help address some of the impediments that were listed in the 2016 document, and to foster that broader ecosystem that's going to be necessary to translate this from academia and the national labs into our industrial base, because it is truly that translation into the industrial base that is key.
I might add that I think our collective sense is that we're at an inflection point with QIS. For many years, and the investments by our agencies go back many, many years, that everybody knew quantum was going to be something very, very important, and we were doing the foundational work. I think especially if you look at industry, you look at what's happening in the laboratories in academia across the United States, there's a sense that things have manifestly changed in the last couple of years, and now we're seeing programmable computers. Chris Monroe from the University of Maryland will be one of the witnesses in the next panel. You have IBM. Both of them have made general purpose sort of programming capabilities available on real quantum hardware at this point. I think that was the dream 5 years ago. We're realizing that reality now. It's going to be a while until we get enough qubits and we can do meaningful computations at scale, but we're seeing this now in the real world. We're seeing hands-on abilities to actually experiment with these systems.
Thank you. Appreciate that. And I will now yield to the ranking